Okay, I'm going to go through this pretty quick for you. I hope you can hear this okay, that the sound is not too fuzzy. Apologize if it is. So, for the golf ball question, how the golf ball question works is we use both the horizontal displacement and the vertical. The vertical lets us figure out how long the golf ball was in the air, and the horizontal will let us know how far it traveled. The 15 meters is important because it helps us find, it is our displacement, because if it's originally at 0, the golf ball is going to end plus 15 meters above the ground from where it initially started. So, as you said, we have an angle of 40 degrees here. We have a velocity of 35 meters per second. This is our vertical velocity that we are given. Angle's 40, and then we know the speed of acceleration of gravity is equal to negative 9.81 meters per second squared. So we have to do both the horizontal distance. So we'll do the horizontal and the vertical. So to calculate our vertical acceleration, what we're going to use is our v of x. We call our v of x for our horizontal distance. We are going to use our lovely cos calculation, and we are going to do the cos of 40 degrees times our velocity, 35 meters per second, because that will give us our velocity, our horizontal velocity from the start in that direction. So our calculations, if we punch that into our calculator, it gives us a total of 26.81 meters per second. So this will help us determine the entire displacement afterwards, because our velocity is equal to our displacement over time. So in this case it is, but we don't have our time. We have the velocity, it's 26.8. We do not have the displacement yet, or we don't have the time. So we're going to use the formula for our vertical calculation, to find out what our time and our distance, what our time is that we travel, or the total essentially the total flight of the golf ball from the time it leaves the tee to the time it lands in the hole. And the formula we're going to be using for that is our displacement is equal to v initial delta t plus 1/2 of our acceleration delta t squared. And I know you're using the v squared one. That'll be for the second problem. So for this one, how we approach to solve this is we need to know what our v1 is, our vertical velocity. So we're going to use trigonometry. So to find our vertical, we're trying to find v1 there. So to find that, our v1 is going to be equal to the sine of, sine of 40 degrees, because that is our angle, times our velocity, which would be 35 meters per second. And then to work that out mathematically, that'll give us 22.5 meters per second. So now we're going to plug in what we know. Our displacement, we do know this. The displacement is equal to 15 meters, plus 15 meters, because it's 15 minutes higher from where you started. So this will be 15 meters. It's equal to 22.5 meters per second delta t plus 1/2. I'm running out of room a little bit. Let's move that over. 1/2 our acceleration, being our lovely gravity, negative 9.81 meters per second squared, delta t squared. Now, how do we find out our time from this? If I were to change it mathematically, it's something we reviewed yesterday, our lovely quadratic formula. So I'm going to change all of this around so it looks like quadratic formula. So I'm going to simplify this, and I'm going to move this over to this side. So by simplifying that, I'm going to get approximately negative 4.9 t squared, or meters per second squared delta t squared. But if I set it up mathematically just to make it look a little easier for us, and then here I'm going to take this next term, and it's just going to be 22.5 t, and then to bring this over gives us a negative, it makes it a negative 15. Minus 15 is all equal to 0. So this is the equation, and now we're going to use quadratic formula to solve this. So punching it, going through the steps of quadratic formula, I will just send you, I will do it on a separate sheet of calculations and send you the picture of it. When we punch everything in, we're going to get two possible answers for t. T is going to be equal to 0.81 seconds, or t is going to be equal to 3.78 seconds. We're going to drop this one, the first one, because it's not logical to hit a golf ball at 0.8 of a second and have it travel. We don't hit at warp speed. So we're going to use 3.78. So this is the time it takes, this is the flight of our ball, the golf ball, from the time it leaves the tee to the time it hits. So now we're going to use our vertical displacement here. So if I want to figure out how far it has traveled, or the distance it has traveled, it's going to be that the velocity we calculated, multiplied by the time it took to travel, seconds, and when we multiply it out, we're going to get a distance of 101.3 meters. So that is how far the golf ball travels. Let me know if you have any questions.